Hello, and welcome to Mr. Ambrose's video on techniques of differentiation. We're going to pick up where we left off in class the other day, where we were looking at some of the shortcuts to find the derivatives of functions. So for an example, we can consider the function f of x is equal to x to the 100th power. Right? So on your test that you had to do today, you had to do the long route to find a derivative. But we know as a shortcut that we can use our power rule to derive this particular function. And the derivative of x to the 100 would be 100x to the 99. So as a practice problem, let's take a look at another function. We can have f of x is equal to 10x to the 5th power. So here we have a function and we want to find its derivative. So I'm going to ask that perhaps you just pause the video and try to calculate what this derivative will be. Based upon what we've done so far, if we just perhaps use our power rule to find the derivative of this function, we would have that f prime of x would equal 10 times 5x to the 4th power. And if we simplify this, we would just get 50x to the 4th power. So this actually kind of brings us to another particular rule of derivatives that you'll need to know. And so this would be rule number 4. And that's going to be that if we take the derivative of any constant times a function f of x, well, based upon what we just did, I claim that this is going to equal the constant times the derivative of our particular function. And for this, I'm going to quickly run through a proof to verify that this indeed will always be true. That basically this constant over here, we can just drag that through to the derivative and then apply whatever rule we may have, which right now we have the power rule. So I'm going to use the definition of derivative to accomplish this. And so for the definition of derivative, I'm going to have to use or find 2 points given this particular function here. So one point will just be x comma c times f of x. And the second point will be our x plus h comma c times f of x plus h. So now using those 2 points, we can calculate our derivative. And so the derivative of constant times f of x will be equal to the limit as h approaches 0 of c times f of x plus h minus c times f of x all over h. And so in terms of trying to algebraically manipulate this, if you notice in the numerator of this whole fraction, we have a c value here and a c value there. Because of that, we can factor out that particular c value from our numerator. And so we'll have the limit as h approaches 0 of c times f of x plus h minus f of x all over h. And based upon the work we've done with limits so far, the key thing is that when we're evaluating a limit, this variable here is what we're really interested in seeing, what's happened to that. Here, h is approaching 0. So as h approaches 0, c is just a constant. It's not going anywhere. So because of that, I'm going to then pull that c out in front of the limit as h approaches 0 of f of x plus h minus f of x all over h. And you may not realize exactly what has happened here, but if you just look at this particular expression here, that is our definition of the derivative of f of x. So this will all equal c, our constant, times f prime of x. So basically, this allows us to, if we have any constant being multiplied to a function, just to really carry through that constant to the derivative, and this helps us quickly calculate derivatives of certain functions. So an example, perhaps, to see this in use, if we have the function f of x is equal to 20 times x to the 7th power, well, the derivative should just be, well, I'll carry that constant of 20 through to the derivative, and then multiply that by the derivative of x to the 7th using our power rule. And so that derivative would be 7x to the 6th power. And if we just simplify this, we would get 140 times x to the 6th power. So now I'm going to ask you to do some problems. Try to do your best to answer the following questions, and then we'll continue the video in just a moment. So hopefully you didn't find any difficulty with those couple problems that I asked you to try. So now we're going to look at this question here, where we have the function f of x is equal to 5x plus 7. And we want to again find out what the derivative of this particular function is. If you really look closely at this particular function, hopefully you realize that this particular function is just a line. So we know that when we calculate the derivative, geometrically, right, the derivative is the slope of the tangent line. So the derivative of this function here, it would stand to reason that f prime of x should therefore just be equal to 5. But this kind of leads us into another rule of derivatives that you should be aware of. This particular function that we start off with is really a binomial expression. It's a sum of two terms. And if we look at each of those two terms separately, we have f of x is equal to 5x, and the derivative of that we know is just equal to 5. And then we have g of x perhaps is equal to 7. The derivative of a constant, right, we said the other day, will always be equal to 0. So when we have a sum of two or more terms as our original function, if we perhaps just take the derivative of each of those two terms, as I've done down here, and then add those two together, right, we can end up with the overall derivative of that particular function. So now I'd like for you to perhaps try to use this particular idea that the derivative of a function is just the sum of all the derivatives of each of the individual parts of the function in this next particular problem. So thank you for, in particular, watching this particular video, and sorry about that little reminder. I got to update my laptop, but hopefully this was helpful to you guys. Hopefully your test today wasn't too bad, and I will see you guys tomorrow. Have a good night.